Hi, good afternoon. My name is Noelle Saillant. I'm Chief of Surgical Critical Care here at BMC and also Vice Chair of Surgery. And I'm really excited to talk with you about field artificial intelligence triage. So the why of what we're doing. So this actually started as a thought experiment that was in partnership with MIT Lincoln Labs and was a DoD directive to basically support a medic in the field or a mass casualty event with trauma level expertise at the point of injury. However, this has rapidly changed in the past 6 months to a year because our military, unfortunately, believes that we may be in a large-scale combat operation in the next 2 years. So the directive has really changed, and they really want us to leverage maximal technology as well as AI algorithms to help our warfighter. The second why is, as Dr. Syracuse says, everything in the military actually leads to civilian development. And so if we develop a great triage model for the military, our civilian trauma centers will certainly reap the benefits of that. And so we basically brought in trauma measures, simple things like vital signs, external injuries, portable sensors, worn sensors, wearables, and natural language models into AI models to help support decision-making at the point of injury and clinical support measures like the diagnosis and treatment of injuries and surgeries, as well as resource allocation like blood and the need for additional surgeons. In the interest of time, I'm going to skip through
Car
the
driver
LLM
injured in
that,
collision with fixed or stationary object in
traffic. So good, it didn't play. So we developed field artificial intelligence in 2018, and we've since been developing it further. We started on a trauma quality improvement, 200,000 patients in the civilian world, but we have since validated on the Department of Defense Trauma Registry, and we also have just recently validated on the Special Forces data set for both individual care as well as mass casualty incidents. And the simple model that we started with was just body mass index, vital signs, and importantly, external injuries, because they certainly dictate injury patterns, need for surgeries, and important outcomes, which the nice way that we built this is the outcomes of what we need can be pivoted based on the injuries and the mechanisms to basically prepare for any type of weapon that we would see, and additionally, any type of outcome that we would need to predict for resources. So some exciting things that we'll highlight. Number one, transfusion. So for instance, we can predict, so you can see the actual transfusion on the Y and the predicted transfusion amount for an individual. For the clinicians in the room, what you'll see is that this clusters around the cooler delivery model of 4 to 5 units so that we can predict what cooler each patient will need at the point of injury. We can also determine by unit what the patient's going to need. So you can see using just EMS or using EMS plus an early second vital sign, we can get areas under the curve of 0.91 about whether they need transfusion, and I can tell you if they need 1 unit, 2 units, 3 units, all the way up to 75 units, because we know 50% of patients will survive with 75 units of blood transfusion, but that may overwhelm blood banking resources. And it also may lead to guidance for things like Dr. Torres's project, where he's trying to send a blood truck out to Canton. Who do you set that to? So at point of injury, you can start directing that resource that is critical. The other thing that we're really excited about is that we're doing a very ambitious project, both for penetrating and for blunt injuries, where we not only identify, does someone need a laparotomy, but we're trying to get down to the point of the exact part of the organ that's being injured so that we can really say, yeah, you need a laparotomy, but you also need a complicated vascular repair, so that at point of injury, we can start activating the system for the vascular surgeon. Or if you're in an austere environment, we can figure out that we need medvac and which hospital to send you to. So it's really exciting work. I will say the DoD has put out significant funding for this in the past year. I think there's exponential opportunity to partner with some of the amazing work and sensors that we're doing here at BU, and we've started some of those talks and are putting forth a vital arc. The last thing I'll say is that while we're making this model for hemorrhagic shock, the exact same model can be repeated for cardiogenic shock, septic shock, and any time-sensitive thing, so we could build infrastructure for hemorrhagic shock for the military, but repeat experiments in other important critical access pathways that would help our patients and greatly expand our research. So thank you for the time.